Alright, hello everyone, and welcome to the Chapter 2 Honors / Scholars Chemistry Study Guide for quiz number 2. Um, we're gonna go through our study guide here, show you some of these practice problems, how to get them, what you really need to focus on, because you're going to start seeing this on the quiz, but also on the test. And this kind of information, especially stuff about chemical symbols and finding elements on the periodic table, is something you're going to be using throughout the entire rest of this class. So I think it's important just to start with that and really get good at that. All right. So here's our study guide. The first thing that we have, and how I'm going to go through this, is just kind of going point by point, showing you where in the slideshow that you can find this information and where in some of these practice problems you can see an example, and I'll do examples of them throughout this video. So the first thing that we have is the mass and the charge of protons, electrons, and neutrons. And I have it in this slide here, so this is slide number 4. But the key idea here is, and I bolded this, is that protons have a mass of 1 Dalton and a charge of +1. So you can think of this like a proton has a plus, right? It's a proton, it has a plus. You need to memorize this. And we can see our protons here in the middle. They have plus signs because their charge is positive. A neutron, it's kind of in the name here. Neutron, neutral. See how similar those words are? Neutral being does not have a charge, but it has a mass. Even just in this image here, you can see how tiny these electrons are compared to our neutrons here. So these have no charge, but they still have a mass because they're much bigger. And finally, we have the electrons. And we're going to be revisiting electrons throughout this whole year, so, don't get sick of them just yet. They're what causes a lot of our chemistry. But we're going to say, and I have the exact amount, but we're going to say that the mass is 0 for our calculations. When we're calculating the mass of an atom, the electron is so minuscule that it does not affect our final results. However, it does have a -1 charge. So this atom right here, if we're looking at it right here, has a charge of +1, +2. So +2 from the protons, -1, -2 from the electrons. This atom would have a charge of 0. And we'll get to these calculations in a bit. So the charge is 0, but the mass would be 4. 1, 2, 3, 4. We don't count these electrons here, but we do count these neutrons. There's 1, 2, 3, and 4. There's our mass. It is nice just to know that this is called the nucleus, the center, and then we're going to say that our electrons kind of orbit around that. We're going to deconstruct this a little bit, this format of an atom, when we start getting into some quantum mechanics a little bit. All right, and I have this here in the very first. This is the mass. I want 1, 1, 0, +1, 0, and -1. So do not confuse the mass and the charge. All right. If there's some way that you need to memorize this, the protons have a mass of 1 and a charge of +1. Neutrons have a mass because they're in the center, but they don't have a charge here. And we're going to say that the electron does not have a mass, but it does have a -1 charge. Okay? And our particles in the nucleus, this is going to be our protons and our neutrons. So moving on to the formula to calculate the mass and the charge of an atom. And this is really just trying to understand what the mass is. This is an extension of the mass of a proton, the mass of a neutron, and the charges as well. And this just kind of helps us understand how many electrons there are. It's going to really start to help when we get into valence electrons later. Understanding how many electrons there are, right? Especially if there's a charge, and we're going to deal with ions, are there more or are there less of those electrons? So I have this here. We go to, and this is just what a Dalton is, why we're using this measurement. The mass is equal to the protons plus the neutrons. So this is one of those two formulas that you're going to need to know. And I'm going to use mass as m is equal to protons plus neutrons. Simple enough, right? And we could also say that the mass minus the protons equals the neutrons, or the mass minus the neutrons equals the protons as well. This is just algebraically solving for this equation. And this is stuff, an extension of some of the algebra that we did, right? If I say that the mass is 10 and there's 5 protons, you should be able to tell me how many neutrons there are. It's the same type of idea here. So if we go do some of the practice problems, calculating the mass of the following atoms in Daltons. Well, right here, if we're talking about mass, we do not care about the electrons. Electrons have a mass of 0. Adding 0 just keeps the same number. We don't care about this. So, instead, we're only going to talk about the protons plus the neutrons. And all we have to do here is just add them up. So I kind of, if I erase here. If I erase here, and we can see 5 protons plus 5 neutrons. This would just be 5 plus 5 gives us our mass of 10. We go to an example down here. 99 protons plus 130 neutrons. And this gives us, what is this, 229 Daltons of mass. Alright, so this is simple. You will get examples, especially like when we go down here, where I give you the mass and I give you the protons, and you need to calculate the neutrons. Alright, so now if we go back to our formula for charge, and we kind of think of charges like magnets, positive and negative. They're arbitrary. They're going to attract one another, and we'll talk about that attraction later. But right now we want to quantify them. All right, so our charges is equal to the number of protons minus the number of electrons. So right here, if an atom has 5 protons and 4 electrons, you subtract them. And you should indicate that it's a positive one. Don't just write 1. Is it negative or positive? It does make a difference because you can have a negative charge. As we see right here, 4 protons, 5 electrons gives us 4 minus 5, and our charge is negative 1. So there is a difference, all right? And then if we go back to some of these questions, calculating the charge of the following atoms, well, now we don't care about the neutrons because the neutrons don't have a charge. Neutrons, neutral, don't have a charge. We don't care about them. So if we take our example here, we have 5 protons and 6 electrons. Get 5 minus 6, and our charge is negative 1. All right, I'm going to go to D right here. 52 protons, 56 electrons. You just take the protons, subtract the amount of electrons, and you get a charge of negative 4. Okay? Simple enough. Moving on, the formula to calculate mass, what an isotope is, what an ion is. So this is just some of the other stuff that I would talk about in here. We'll get to here. So I just want to go in the order that I have this in the study guide. So an isotope, all right? Isotope is the same element that has a different mass. However, what determines an element's identity, I guess I have to start here then. What determines an element's identity is the amount of protons, and this is the atomic number. So when we start looking at our periodic table, where is it? And we start looking at our atomic number, this means that any hydrogen atom has 1 proton. That's what this means here. If we go to, why did that got cut off? We go to carbon here. No matter what, carbon has 6 protons. Every single atom of carbon has 6 protons. But you can have atoms that have different masses. So if we go back to here, and I'm going to go to the next slide here. If we have carbon that has 6 protons and 7 neutrons, goodbye. 7 neutrons. Then the mass would be 13. But if we have another atom of carbon that also has 6 protons, because this is what makes it carbon, but it only has 6 neutrons, our mass is equal to 12. Put this over here. Our mass is equal to 12. So they are the same element, but their mass is different. 13, 12. They have different masses. And the reason is because of the amount of neutrons. 7 neutrons here, 6 neutrons here. So what you need to remember about isotopes, they are the same element, so they have the same amount of protons, but they have a different amount of neutrons, which is why their mass is different. And we're going to spend the upcoming week on our isotope lab, and we're going to start to deal with isotopes. And that's why this number right here is not exactly 12, because those isotopes exist. We're going to get into all of that. All right, we're going to ignore the atomic weight for this quiz. This is our atomic weight, what I'm circling right here. We're going to ignore it because I don't want to confuse you with what I've been talking about so far. We're going to get to this. Okay. Um, and then finally we have ions, where an ion is just any atom that has a non-zero charge. Non-zero being +1, +2, +3, -1, -2, -3, and so on. Okay. It's something to know because we're going to deal with ions. Many atoms, most atoms, don't have charges. They have a charge of 0. And all this really means is that uh, there's electrons taken away. You can't change the amount of protons, but you can say, here's an atom of carbon, and I have a charge of +3, let's just say. It still has 6 protons, but if I remember my equation, charge, and I'm going to use C for charge, is equal to the protons minus the electrons. Well, my charge is 3, and I have 6 minus E. Well, we do a little bit of algebra here. We're going to do plus E on both sides. So we get E plus 3 equals 6. And we're going to subtract 3 equals 6 minus 3. And we would have 3 electrons. Okay? So you should be able to do this as well, where if I give you a charge, you can calculate the amount of protons or the amount of electrons. And we'll see this when we get to some of the final practice. And then I just have these two terminologies. If a positive charge is a cation, I tell you, the way that I remember this is just cat plus. It makes no sense. It's not even a good mnemonic, but for me personally, that's what I remembered. And maybe you'll remember it too because of how stupid it is. Cat plus, this is a positive charge, so this is a cation. Negative charge, if you had this with a, I should have written it like this, with a -3 charge, this would be an anion. Alright, so heading back here, what an ion is, differences in protons and electrons, it's what causes it is due to the electrons. What the atomic number tells you about an element, I wrote it here with 4 exclamation points, so you really remember it. That is how many protons there are. And then how to find the atomic number and the atomic symbol, you will get a periodic table on this quiz and for a lot of the rest of the class. So if we head back to here, this right here, this is the atomic number at the top. This is the atomic symbol, and this is our element name. We're going to get back to our atomic weight next week. All right, we're going to get there. So the atomic symbol is 1 or 2 letters. So here we see, just as an example, and I'm going to erase our screen here. If we go to copper, here's copper. Or sorry, not copper, this is cobalt, excuse me. Cobalt, the first letter is capital, the second letter is lowercase. There's 27 protons in every single atom of cobalt. We go to copper, now we're at copper, it is Cu. Alright, so it's a little bit different. And be aware, there's a few of these elements where the symbol does not match the name. Sodium, potassium, where are we at? Tungsten, gold, silver, even copper. There's no U in copper. Mercury, tin, antimony. And I think that's all of them off the top of my head. Um, oh, lead. There we go. So I'm pretty sure that's all of them, but just be aware of those because I will start talking about sodium and I'll write the letters Na on the board. So if anything, would probably going to need to know these two. We're going to use sodium, potassium a lot throughout this year. These are the ones we'll use the most, and I just looked. I forgot iron. Here's iron. So if you were calling out Mr. Raiden, you forgot iron. I didn't, but that would be a good catch. All right. How to write out this ion notation. So just what this is, ion notation. This is when I write out an ion. So if we go back to the example here, and I wrote it here, and this should be backwards, so I'm just going to erase this so that I can put my money where my mouth is. When you have an ion, so let's say whatever it is, you put the atomic symbol, and this is a shorthand because we're going to see this shorthand a lot. So here's our atomic symbol. So this would be carbon. We put the charge, the number of the charge, and then we put the sign of the charge. So I'm going to put a square around where I've been typing here, right? This is our kind of our structure of this. You take the atomic symbol, you put the charge, the number of the charge, and then the sign. Now, if you have something, I'm just going to clear this out. If you have something where you have a positive 1 charge or a negative 1 charge, such as chlorine, potassium, the positive 1 charge, you don't write the 1. There's kind of an invisible 1. You know, we don't write it, but you could think of it like a invisible 1. Okay? That's our ion notation. Oh, and this element here, I'm just going to say this because it's a reoccurring thing. This is chlorine. Um, this is chlorine. This is an L. I understand that it looks like an I, and it's annoying because a lot of fonts have the L exactly the same as the I. This is iodine, Cl. This is iodine with an I. So please don't mess that up, right? I understand it's easy. This is chlorine. This is an L. Because this has to be a lowercase letter. The second letter must be lowercase. Here's an I, nickel, where the I is lowercase. Just want to be upfront as possible with that. All right. Lastly, we have the charts like this. And these are some of the examples I took from this assignment here. All right. Um, a lot of these questions, and I do have these answers, the answer key posted as well. But what I want to kind of just go through is the rest of these, or at least some of them, of these practice examples, because you're going to get at least some of this stuff, or stuff like this, on a quiz, and further away on the test. So if we just look, iron, I'm just going to take it, our atomic number is 26. We go back up here, here's iron, 26 is its atomic number. Where are we going? Got so much stuff here. Alright, and then the mass. If I say that the atom has a mass of 55, and you might be like, whoa, well the mass is 55.845. Do not use this mass yet. I'm saying that this is a specific isotope of iron that has a mass of 55. I want to be clear with that too. This is a specific, oh, I'm getting confused. This is an atom that has a mass of 55, a specific isotope. There are other isotopes of iron that have a mass of 55 or 56 or 57, but this one has 55. So if we take our formula, mass is equal to our protons plus our neutrons. I say that the mass is 55. I said the atomic number is 26. Atomic number is the amount of protons plus our neutrons. So all we have to do is just subtract And we get, what is this? N equals, is my math failing me? Should be, just want to bring up the calculator. You think I could do mental math? 29. All right. And there's 29 neutrons. All right. This example here where I talked about isotopes, I say that you commonly see isotopes written like this, where you'll see carbon-14. We'll especially see this when we get to nuclear chemistry, but it is kind of nice to know just for now. And we'll probably use this when we use our penny isotope lab. So what this is an atom of carbon, and the mass is equal to 14. How many protons and neutrons do each of these following atoms have? Well, this is carbon. Here's carbon. Carbon, just like every other atom of carbon, has 6 protons. So you already know that there are six protons in all 3 of these atoms. But the only thing that changes is the amount of neutrons. Carbon 16, or carbon 12, excuse me, has 6 protons, so there's 6 neutrons. 12 minus 6. Carbon 13 has 7 neutrons. And carbon 14 has 8 neutrons. Because they all have the same amount of protons, but their neutrons are different. This is what makes them isotopes. Finally, last but not least, we're going to get to a table like this. And what I want to have on the screen here is the 2 formulas. These are what you're going to need to use. I'm going to use the shorthand. I'm going to use mass is equal to protons plus neutrons. I'm going to use charge is equal to protons minus electrons. This is all the information that you need to know to solve this. Besides taking atomic symbols and putting in the like protons. So let's start here. We have Pb2 plus. Well, this 2 plus right here, I'm going to zoom in here. Just going to keep my stuff. It is. It's not. There we go. So right here, 2 plus, this means my charge is positive 2. Right off the bat. Let's go to our periodic table. We find Pb right here. Here's lead that has an atomic number of 82. So we know that there are 82 protons. Well, let's keep going. So I have, for the first formula now, I have my mass is equal to my protons plus my neutrons. I have my mass, I have my protons, I can find the neutrons. So our mass is 207 is equal to 82 plus our neutrons. Whip out the calculator. Take in no chances with my mental math right now. And we get 125 neutrons. Now we go to our second equation here. So now we're on, I'm going to mark this as equation 1, equation 2. Well, my charge is positive 2. So I'm just going to write this as 2 is equal to the protons, which is 82, minus my electrons. Then we have to just do the algebra here. And this is that same idea. This is why I wanted to reiterate algebra, because you're going to get algebra throughout this class. And it's expected that you're able to do this level of algebra. Alright, so we add e to both sides. 2 plus e is equal to 82. Negative e plus e, these cancel out. And then we get 2 minus 2 plus e equals 82 minus 2, and e equals 80. And there are 80 electrons. Alright, and you can do this type of stuff with these 2 formulas with any of these equations. So I'm going to just do one more, just to show you. There's 3 things that you need to know is these equations right here, and how to find the atomic symbol and matching that up. So there's kind of 2 parts with this question. Let's go to, what's a good one to have? We'll take this one. So first and foremost, let's look what we have. we have our mass. Our mass is 93. Let's start with equation number 1. We have 41 protons, but we don't have the neutrons. Okay? So we can calculate our neutrons. 93 minus 41 gives us 52. There's 52 neutrons. Well, I can calculate my charge here because my charge is equal to my protons, which is 41, minus my electrons, which is 36, and this gives us a charge of positive 5. So we have positive 5 here. Now, last but not least, I need to find my atomic symbol and write this out in ion notation. Well, I have 41 protons. Let's go find element number 41. And we find here is element number 41, niobium. Some of these are tough to pronounce. Um, so our atomic symbol is Nb, and we're going to write out Nb. We're going to write the number and then the charge, 5 plus. Okay? The other thing too is that you can gain a lot of information, and I guess I'll just do this one final one here. Right here, there's no charge here. There's a charge of 0, which means our charge is exactly 0. And what that means, well, I know I'm looking for potassium. Potassium has 19 protons. My charge is 0, is equal to our protons, 19, minus our electrons. Well, our electrons is also 19. And then the mass, then we can subtract our mass minus our protons, and we can get our neutrons. All right. So this is all for your for this review. So this is just some practice, and I wanted to do at least some of these examples and show you what the key ideas were for this. And I wanted to get this ahead of time so that you have the ability to study this. So have a wonderful time studying. All right, and best of luck.